Hello everyone, and welcome to Eonics Hack Night. My name is Amir, and I'm a Java developer working for Eonics. And currently, my assignment is at a BMW in Breda. And feel free to connect. And before I start, who is a Java developer?
I think you should take a picture of them.
who is better as who is not a Java developer? Okay. Okay, at least I have Harsh over there. So. And yes, before I start again, I started to learn Dutch. So the more I learn Dutch, the more I forget English. So I'm originally from Iran, so we might end up speaking in Persian at the end. So we'll figure out. Yes, let's go quickly over the discussion that we are going to have. So first we compare reactive system with reactive programming. And then after that, we start a journey all the way from Java 1, pretty old, to Project Loom, which was released 2 months ago. And during this journey, we talk about Reactive X, basically RX Java, and Project Reactor. And then we talk about Kotlin coroutines and, of course, Project Loom. So why I started with reactive system? Because I realized that this reactive system and reactive programming, they are confused very often when people talk about it. So first, let's start with reactive system. So we go to 2013, and a group of developers leading by Jonas Bonner, they came together and they create a document basically to show the fundamentals, the core fundamentals of a reactive system. And what are the fundamentals of a reactive system? The first one is to be resilient. Basically, this means that the system should stay responsive when a random failure happens. And this should be achieved by isolation and replication. And this is the first, basically, fundamental feature of a reactive system. The next one is to be responsive. So the system should respond very fast and in a consistent way. So this means that the quality of the service should be very high. The third one is to be elastic. Again, the system should stay responsive, but this time not when the failure happens. This time when unpredictable load is coming. So the system should stay responsive. But this can be achieved by a cost-effective replication. And the last fundamental feature of a reactive system is to be message-driven. This means that the components of a system should connect to each other using an asynchronous messaging. But the more important thing is that a reactive system is not equal to reactive programming. A reactive system is a very broad topic. This includes architecture, includes DevOps, includes also networking. But obviously, one biggest step towards having a reactive system is to use a reactive programming. So I have a definition here from what is exactly reactive programming. So I'm going to read it: a programming paradigm focused on handling asynchronous data streams. What does this mean? So when we talk about reactive programming, there are quite a lot of keywords. So I put some keywords here to just get familiar with this one. So what is a paradigm? Basically, paradigm is a way to classify programming languages. And when we talk about paradigm of Java, originally Java was an object-oriented programming language. But the good thing, I believe, about Java is that it's gradually added other paradigms to the language. For example, aspect-oriented programming. Where is my photo? aspect-oriented programming or functional programming, Java gradually added all the. Can I have the button? Say, yeah. Thank you. Oops. So the thing that I like about Java is that Java adds other paradigms as well. So originally it was an object-oriented programming language, but then it becomes declarative. And then in Java 8, it becomes functional. And then when we have functional, we also hear about operators. Then we talk about handling. What is handling? When we handle something, basically we look at something and we are waiting until something happens and to react about it. So if you see observers in some libraries, this means that we are handling something. If you hear propagation of change, this is all about handling. And of course, asynchronous. So asynchronous and non-blocking are not exactly the same thing, but they have a lot in common. And the last one is data streams. So when we talk about data streams, of course, we have some observables. Some libraries call it observables. Some people call it messages. And of course, something to be observed and to do something based on a message, it can be called events. So I have an example about a comparison of an imperative programming and reactive programming. So obviously it's a very simple example, but let's have a look. So I have it's not Java, sorry, but it can be Java, of course, but I have a variable assigned to 1 and a variable assigned to 2, and basically I am assigning A equal B plus C. So no matter if I later assign 10 to B, then when I print A, I'm going to have 3. Why? Because this is an imperative programming and this is a statement. Basically in this statement, I'm saying that a state of this variable should change now. I'm instructing what needs to be done. On the other side, I have a reactive programming. This is not a real code, but imagine we have this magical operator. So again, I have B equal to 1 and C equal to 2. And then, thanks to this magical operator, I am declaring that A should be equal to B plus C. So this means that if I later assign 10 to B and I print A, I will get 12. And this is basically the idea of having a reactive programming. And again, coming back to our terminology and our keywords, B and C are observables here. And so it can be also events. So when we change B, it's an event to propagate this change. So one more thing that about reactive programming in Java is not entirely something new. So it's a mix of current technologies, current paradigms, and patterns. So sometimes we mix a current technology and a current paradigm, and then we build something new. And why is important to know the history? Because we as developers, we are not always working on JDK 19, of course. There are companies still using Java 8, and to me, yes, to me, when I understand why it's evolved like this, then it helps me to write a better code. So it's always a matter of question. If you have difficulties writing a piece of code, then you might think, oh, am I doing it right? Or there might be something that I'm not aware of. So that's the importance of understanding the history of reactive programming in Java. So let's start. The most reactive code ever, Java 1. So this is introduced in Java 1. So basically, we are creating a thread, and of course, we can pass a runnable, and then we can do something asynchronous in this thread. And when we start this thread, this will be executed. as a Java developer, if you are working somewhere, please don't write such a code, so you will be in trouble. So, but still, this is something. So this is asynchronous, and you don't need to write in old days, 1996 something. You don't need to write native code, so it's something. It's level 0 of reactive programming. But what if I want to return a value from here to the main thread? It is possible, but it is not very straight, and it's very error prone, right? And next, what if I want to handle exception here? So the exception will happen in this thread, and then the main thread is not aware of the exception. What should I do then?
Ignore it.
That's it. So the next milestone is Java 5, when we have futures. And we have other classes like executor service and callable. So this is the key here. First, we have executor service. Of course, it's a thread pool. It helps us to manage threads. And, but the key is here. So in Java 5, we have genetics. And you can see that this future class is accepting a generic type. So this means that I can return something to this future. So the returning value problem is solved. But still, there are some problems. When I submit a callable is a new type that is introduced in Java 5. If I submit this callable, but I'm not sure is it done, so it has a is done method. So if I want to make sure that it is done, I have to have a loop, a blocking loop. So is it done? What if it now? Now, and then I can execute my next logic. So far, returning values, this guy is happy. Exception handling is kind of happy. I would say this is not exact exception that we get, but we get some exception and we can extract the main exception. But what if I want to chain one or more tasks together? So when it is done, when I get the token, I want to request an order. But this is very difficult with Java 5 futures. And then we came to Java 8. Java 8, I have to say, is a very big milestone. Some companies are still using Java 8. I don't know. But Java 8, we have completable futures. And thanks to Java 8 functional programming, we have these kind of very famous interfaces. Basically, they introduced Lambda, and we have supplier, consumer, and function. In a supplier, I know that you already know this, but I just quickly go through this. Supplier is a method that doesn't accept anything, but returns something. A consumer is a method that accepts something, but it doesn't return anything. And a function is a method that accepts something and returns something else. And thanks to these interfaces, in completable futures, we can chain the tasks. Before I go through these different overloads, I have to say, if you check the source of completable futures, it's more than 3,000 of code. And it has around 100 public methods. Probably if you say, oh, it's not the best design, but I will explain why. So in the completed feature, you have the methods to basically chain every possible combination of these interfaces. So you have then supply, you can pass a supplier, you have then consume, you can pass a consumer, and so on. And apart from that, of course, when you want to chain something, you can use then methods, then consumer, then supply, and sometimes you want to combine something. When something happens and task A and task B is done, so then we want to do something. We have then combine method, and that's one of the beauty of completable futures. And apart from that, when something happens, it's also provide exceptionally. So no more try catch, thanks to this exceptionally. So basically, when something happens in the chain, then it will give you the exception and you can do something about it. So let's look at some examples in using completable futures. So I can start a completable future, and this is just I try to become a bit realistic. So this is an example that I request first a token, and I call a service to create an order. So this task needs to be sequentially combined. So then first I use supply async. I request a token. This can be a blocking. So using this, I can make sure that it's happening on another thread. I am not blocked. And then I can pass using a then apply async. I can pass this token to my order service or whatever, and then I can create the order. And again, this is another overload of the completable futures. Then I can send my order number and notify the customer. So this is the way, as an example of chaining tasks sequentially. What if I want to do in parallel? So imagine in our example, preparing the drinks is not very related to submitting the order. So I can have one completable future here. So, and then this is a separate completable future. And then this part is the same, but in this line, I can combine two completable future. So you can see that as a first parameter, I am passing the first completable future, and this is a by function. So it accepts both, and then we can, here just for sake of example, I am combining two strings together, and then I can do something with the result. And of course, exceptions. So again, same example. I'm requesting a token. That's okay. And I am creating an order. And then there could be an exception. Something like the burger is lost. And then when the burger is lost, the customer is both angry and hungry. So what should we do? There is no, thanks to completable future, there is no try catch. And then I can use exceptionally. So I get the exception, I have to do something. So I can call the customer service and say good luck with this angry and hungry customer. Yes. And one more thing before we go to the next step, you can already feel that it's changing from a classic thread to a pipeline which has operators, and it's basically changing the style of writing code. So let's overview the Java 8 completable future. We have a sequence chain. This guy is happy. Oh. We have a combine chain. This guy is still happy. We have functional, so we can pass functions, operators. We have event streams. Of course, we can send anything to our pipelines. And then, but it's all about demanding something new in the development world, right? What if the developer might say, what if I want a rich set of operators? Yes, I have supply, I have apply, I have consume. But what if I want to filter? What if I want to map to something else? What if I want a rich error handling? Apart from getting exception and doing something, I want to resume on some such error. Or I want to retry on some basically operations. And one of the most important thing is back pressure. Back pressure is a wide topic, and it's obviously out of the scope of this presentation, but I have one slide just going over the back pressure. And having all these unhappy guys, we end up to these libraries. So Reactive X and Project Reactor. What is back pressure? Basically, when we have our pipeline, so we can imagine that a producer is producing something and the consumer at the end is consuming. But it can be the case that the producer is producing faster than the consumer. So what needs to be done? Basically, in a simple word, we are turning off the tap. But how it can be done? Basically it's called a mechanism called back pressure. And if we don't have back pressure, we can end up having memory overflow, system latency, and a system can be unstable. Before Java 9, libraries was doing something, but thanks to Java 9, Java is always tries to standard things. So we have these two interfaces, flow.publisher and flow.subscriber. These two interfaces allows us to basically signal the producer that is slow to slow down. And reactive programming libraries such as RxJava, Project Reactor, and Akka streams, they all implement this back pressure. How do they do that? Of course, there are quite a lot of details, but I'm going to quickly go over these constants that they have. For example, in RxJava, we have this strategy of drop, simple. So if it is producing more than the consumer that consume, just drop and remove it. And we have the strategy of buffer. For this one, it is ideal if you have enough memory, so you can buffer things. And then we have latest. Latest means that it's ideal for monitoring applications, so you're more interested in the last value. So you don't care about the values in between, so you get the latest one. And in Project Reactor, we have all the corresponding methods like on back pressure drop, on back pressure buffer. Coming back to our journey, so we talk about ReactiveX. ReactiveX is a mix of paradigm and library, and it was originated by Microsoft in 2012. Basically, they introduced it as a reactive extension for .NET libraries, and later they decided to port it to all programming languages. So we have all implementation for most popular languages. For Java, it's called RxJava. We have Rx Kotlin, Rx Python, RxJS. They are all implementation of ReactiveX. And their goal is to have like a uniform programming model for reactive systems. I have to say, RxJava is widely used by famous companies like Netflix and Alibaba, Microsoft, Pinterest. And one more thing that I like about ReactiveX, I've worked with ReactiveX, is about community. They have a very strong community, and this project is still alive. So if you check the GitHub, there you can see commits for 1 day ago, so it's still alive. And in RxJava, the key concepts are observables, operators, and schedulers. Sounds familiar, right, to the keywords that we had? Oh, sorry. And here I have one example of our ReactiveX RxJava. As you can see that I'm creating an observable of integer, and here I have a method called range. So they have, remember the demand was to have a rich set of operators. So we have a set of operators to create. For example, here I'm using range, but there are other options, and I just picked some screenshots to show you how rich is the library. And then of course we have filtering, and here I'm using a filter, but you have also filtering like sampling, skipping, distincting, and all the methods for doing the filtering. And of course we have transferring observables like flat map, map, group by. And what this code is doing, it's you're all Java developers, so you know, but I'm just going to go through it quickly. So I'm creating a range of observables from 1 to 10, and I'm filtering the ones that are not even, and then I just map them from an integer to a string concatenation of value, colon, and the number. And this flat map basically is replacing one observable with something. And what is the something? The something is another observable, including value and value plus doubled. And of course, there are some exception handling there. And when I run this code, the value would be something like this. So you can see that I have value 2, this one, and I have value 2 doubled. So this is an example of how you can work with ReactiveX. And then we come to Project Reactor. So in my previous project, we were using massively Project Reactor, and it was like a very nice experience working in Project Reactor. At the end, we managed to create systems that was handling 15,000 tickets per day without, and it's live still, the system. And we have also tonight a workshop on Project Reactor. So we go a bit deep to how to use a Project Reactor. I was talking with some guys before this session, and they said we use every time we try to use Mono and Flux, we end up not using it. So if you are interested, wait and see how we can play around Mono and Flux. So what is Project Reactor? Basically, there is another specification, reactive streams, and Project Reactor is an implementation of reactive streams. And if you are a fan of Spring, who is using a Spring? Everyone. We are not using a Spring in BMW, but if you are a fan of a Spring, so Spring developers worked on Project Reactor, and it is mainly used in a Spring Web Flux framework. So this is kind of a Springish way of doing reactive. They also, of course, they have a rich set of operators, schedulers, whatever, and they support, I show you, they have methods and support for back pressure. Before we enter to workshop, I'm just going to go through these two main types of Project Reactor. In Reactor, we have Flux and Mono. So Flux basically represents an item of 0 to n. And for Flux, it supports back pressure. And a Mono represents a 0 or 1 item. And this 0 or 1 item can be also an error signal. So in the workshop, we'll talk about this, how is the signal is emitted, how can we make it empty signal, how can we recover from empty signal, and these kind of things. Just a quick example of a Project Reactor. You can see that the syntax is more or less very similar to ReactiveX. So I'm starting with a burger object, and I'm filtering. Of course, when I want to do a reactive call, a non-reactive call, I have to use map. So I change my burger to a burger request, still one object. And then when I want to do a reactive call, I'm calling a client. One thing that you need to consider when using these reactive libraries, your whole stack needs to be reactive. We'll go through it in the later slides. You have to be careful if you are using reactive, and for example, you have a library that is not is a blocking library. You might have some issues there. And then when I book my burger, actually, and then I adopt my burger response to an event, and I publish some events. So you can see that this is, I swear, this is reactive this time. Oops. But it's all about demanding something new, right? So you can see that the coding style is different. This is more or less, and I remember when I was working my previous project, I was talking with my friends, then I was like, okay, this is not like the code that I used to write in Java. All your code is like this. Imagine you open the code, and there is no single line of a statement. All is like this. And you can end up in a non-readable code. Sometimes it's very difficult to read such a code. And of course, I mentioned already that, for example, if you want to go to the database, we have JDBC, but it's not a good idea to use JDBC with Reactor. You have to use R2DBC. It's a reactive library of working with database. One more issue with, I already mentioned this one, so we have to handle the blocking parts ourselves. And one more issue with this writing code in Project Reactor is about debugging and stack traces. It's not very straightforward to follow what is happening. Basically, IntelliJ IDEA has a very good support of reactive debugging, but still, it's difficult. And then we end up to this question: can we write our regular code and be reactive? And the answer is Kotlin Coroutine and Project Loom. Let's see what is Kotlin Coroutine. Usually, in a normal world of execution, we have a CPU which has some cores which are executing our code. And on the next level, we have operating system. These are the threads of operating system. Sometimes it's called kernel threads. And then we have our Java application is a JVM classic thread. And these are very heavyweight threads. Basically, this is one of the reasons that we are talking about reactive. These threads are very costly to create and to block. So if we block one thread, it's very costly to operating system, to CPU. You need context switching if you want to go deep into the operating system context. And one more limitation about this classic thread is that per 1 gigabyte of memory, you can have maximum 4,096 threads. So if you are building big applications, you can imagine that in a classic Spring MVC application, for example, for each request, you're assigning one thread. So it might be the case that your application is running out of the threads. And then Kotlin coroutines comes to rescue. Basically, these are lightweight threads which are built on top of the threads, and these are like JVM internal threads. And one classic thread can have multiple coroutines, and in total, I think we can have millions of coroutines. So if we write a code which is blocking, so imagine we call a burger service, and we have to wait until the responses come back. It's not a problem. We have millions of coroutines. So that's the way that Kotlin is answering that question. Why, if I want to write a regular code, and it is reactive under the hood. So we can have millions of coroutines, and the Kotlin will take care of everything under the hood. There is a very famous example on YouTube and on documents. So we are comparing Kotlin coroutines with Java threads. Basically, this is an example of Kotlin coroutines. I am just creating 100,000 coroutines. This is thanks to IntelliJ, it's showing that this is the coroutine scope. And I'm not doing anything. I'm just saying, wait 1 second, and then print a comma. So if I run this, everything is OK. So if you run this, you can count 100,000 comma will be printed if you want. But if I write the same code using threads, so this is more or less the same, but instead of coroutine context, I have a thread here. And again, 100,000 of threads. I will end up having out of memory. Basically, the JVM says I cannot create more threads. How to write a regular code in Kotlin to handle to be reactive? This is an example. I have order function. I'm getting token. I use that token to create an order, and at the end I want to send an order. And all of these methods get token, they can be blocking. So thanks to Java features, it's already complaining that you are having a blocking call inside a non-blocking context. So this is a beauty of Kotlin. So it forces you to mark your functions. It's easy to mark your functions with suspend, and then it will be non-blocking under the hood. It is non-blocking if I want to be precise, it is suspending, not blocking, suspending the coroutines, and it's not blocking the threads. You might ask, okay, I'm writing Kotlin code, and how can I implement the parallel logic? So thanks to Kotlin, we have this async keyword. So again, same method, request rings, and I can just start my code with async, and we have this method await. Basically, the moment that this line is executed, there would be another coroutine starting executing this one, and same happens here. And if I want to wait for a result, I can just call await. And since it's all handling by coroutines, there shouldn't be a problem. And in Kotlin, there is also another topic called lazy composition. Sometimes I just want to create a task, but start them when something happens. So thanks to Kotlin, there is a coroutine start.lazy. I can pass, this is again the same as async, but I'm passing an extra parameter. So basically what I'm saying is that I might have a task of sending SMS, but it's lazy. And again, sending email, I might have a task about sending email, but it's lazy. And then I'm checking some logic, but if it is true, then I can start. So this way, you can start the task. And again, if you need both results, you can just call the await method. Sorry?
You want to do chaining? Like, I don't know, send the email after?
Chaining, it was already covered in the regular code, so it's like a chain. So I'm using the token and sending to the next one.
Yeah, all right, so it just doesn't look like chaining.
Yes, it's you can write regular code. And the last one about Kotlin is, what if I want to retry? So in Reactive, you saw that you can retry something like 10 times. So how can I have something like retry this? And thanks again to Kotlin. So they are creating a new language. They can do whatever they want, right? So they have something called higher order functions. How does it work? So I can basically create a function. Of course, it needs to be marked as suspend, and it's accepting basically a lambda. And the name of the parameter, I'm calling it block, and it should be suspend. So what this code is doing is like a while true until try until it doesn't throw exception. And Kotlin supports such a structure to create a retry like this. And next, what is Project Loom? So Project Loom is a relatively old project. 2018 is old in software development, right? So Project Loom is a project internally in Java, and they created already. It is released a couple of months ago in JDK 9. So it's a Java VM feature. So basically, they are creating a new way of having threads. They call it virtual threads. And it has a lot in common with coroutines. And Java is, sometimes Java wait until the other languages does something and then brings it in. So it's very similar to Kotlin coroutines. And it was previewed in JDK 19. And a couple of months ago, I think it's released as a final. And one very cool thing about Project Loom is that they have forward compatibility. We'll talk about forward compatibility. What is forward compatibility exactly? In Project Loom, we have virtual threads. And again, very similar to Kotlin coroutine, they are very cheap to create, to block, and to resume. What is important to know is that they are internal Java entity. So there is not like an external library like Project Reactor or Reactive X. And the virtual threads will have their own memory stack, of course. Very simple example of creating a virtual thread. We have the same thread class. We can call a start virtual thread. You saw already in coroutine we have scopes, and here we are creating virtual threads. But how can be forward compatibility? Very important thing about coroutine, Reactor, and RX Java. I already mentioned that if you want to call something that is related to old classic blocking libraries, you might have a problem. Why? Because imagine you have some coroutines, but somebody needs to manage these coroutines. And if you write a code that blocks these schedulers, then there is nobody that to manage these coroutines. That's why you have to be careful. So anytime working on coroutines or ReactiveX or RX Java, you have to be careful when you are working with blocking libraries, old blocking libraries. Unless, of course, you can have a thread pool and assign some threads to keep it under control. But in project room, the goal is to enjoy the existing code. How? In project loom, since they are writing Java, so they are creating JDK, basically they rewrite the old Java API libraries. This is not a real code, but you can imagine there is such a code that if the coming thread is a virtual thread, then don't block the main thread, just suspend it. So since they are writing the JDK itself, they have this ability to rewrite these libraries. And this will end up in a way that, imagine you have your application, a blocking application. On paper, you can change the JDK version to the latest one, and boom, you have everything non-blocking. That is the feature of Project Loom. So just to compare, using Reactor, RX Java, and Kotlin coroutine, if you are working with non-blocking APIs, completely fine. If you are calling with Java IO, Java concurrent, you might be careful about that because you might have some problems. Project Loom, of course, perfectly fine. And thanks to forward compatibility, you can easily call the old APIs. And that was it.
Maybe there are questions.
Of course. No, you cannot have questions. Yes?
You're talking very much about an evolution in functionalities and operators and logic, right?
Yes.
But this is all still, I would say, logic which was pre-programmed, right? Which logic would you expect to be part of future programs, also using intelligent or artificial intelligence? Because you see that already a lot of programmers are using, for instance, something products from OpenAI. Do you expect in short, longer term that to be implemented to Java?
Yes. First of all, Mitchell told me that I have to repeat the question, right? If I understand your question, so we talk about the evolution of the writing reactive code in Java, but you're more wondering about using AI in. Well, it's very. I have to say it's a very wide question to answer, but the way that I can see it, it's hard to answer. But the way that I can see it is the evolution of the programming would be always there, and what AI can do is just to basically optimize and help developers in writing something new. So far, I don't see AI basically writing a logic of a program. I hope that I answer your question.
In every step, you add
Yes.
Drawbacks in the last.
Some happy and non-happy.
Exactly. So
Yeah.
we had some unhappy phases with all the solutions, right? So basically, you said, okay, it's all about what you want next.
Yes, yes.
Is there any unhappy phases in this last Project Loom solution? Would there be anything that you feel that right would be awesome if they had that?
Very good question. So JP is asking, so in each step in our journey, we have some drawbacks, basically demanding something new, and we kind of address the issues. And he's asking about drawbacks of Project Loom. If I go back to that slides, here, of course, here we are talking a very high level. It's out of the scope of this talk to go deep. We'll go deep about projects, a bit deep in our workshop. But one drawback that about this is about context. So imagine you can consider this pipeline. Oops, here. This pipeline. So we didn't go much into the details, but what if you want to pass a context through all of these steps? And what I have seen so far, Kotlin coroutines and Project Loom, they are in competition to handle this context. Imagine it's very famous MDC context for logging. You want to pass something, we cannot write a production code without logging. And this guy, if it wants to log something, it has to be aware of context. And having a context, multi-threading, multi-coroutines, it's a bit complex. And I have to say the drawback of Loom, it's very new, but what I hear from people is that is about handling context.
That will be the next step.
Next step, yes.
Okay, cool.
So you were talking about coroutines and the usage under the hood by the JVM of lighter threads,
Yes.
which will enable millions of threads instead of the 4,000 something threads that are the heavy threads that is used by
Yes.
Java. And now this is implemented in the Loom Java 20.
They call it a
right?
virtual threads.
So it's actually, let's take the problem that Tomcat has, because it uses those heavy locking threads.
Yes.
Would that, without any change, automatically be able to handle more threads?
Yes.
So that's because why would I still use, for example, Webflux? That's actually a question I was thinking. Would it be a negative effect for the implementation of the Reactor project?
Again, a very good question. So, sorry, I forgot your name. Safe asked. Yes, thanks to Project Loom, the goal is to just change the JDK, and boom, you have reactive. Why would we use Project Reactor? First of all, Project Reactor is a very good option for handling streams, apart from all of these discussions. But yes, in this is one of the reference of this talk. If you go and watch this video, there is a sample case. There is a Spring MVC, which is using against JDK 11 or something, and they put it under load, and then the application crashed. Basically, they changed the JDK, Tomcat, and no Webflux, no Mono, and boom, the performance is awesome.
So then, if you put the two in a competition, a well-implemented Reactive Webflux implementation and the Tomcat, and I'm guessing underwater that they are going to be using similar technology, because the virtual threads are using similar mechanism as the ones that are being used. Because
kind of yes, but not totally.
Okay, so which one would win?
That's a very good question.
Okay.
But the important thing that I arranged this presentation, if you know how it's being evolved through the time, when you are changing the JDK, of course, it's not as easy of just changing the version and goes. Of course, it's not like, but once the more you know, the easier the migration would be. So that's the idea of behind this presentation. You have to know what are virtual threads. You have to know what is forward compatibility. Of course, there are some exceptions for forward. When you know there is this evil syntax in Java, synchronized, open bracket. So if a library is using that guy, then we are going to have problems. So, or you have some old companies might use a code that has native thread call, then we are going to have problems. But yes, to answer your question.
The presentation was very, very nice, and it's very enlightening also.
I'm happy to hear that, but to answer your question, that nobody knows basically.
Yeah, I gathered that.
Yes.
Any more questions?
Yes.
Well, if we think about Kotlin threading model, and if we compare it with the virtual threads,
Yes.
what do you think? Does it make any sense to continue using Kotlin or completely move to Java 21 and virtual threads?
That's a very good question. And so just to repeat your question, so you are asking, yes, we have Kotlin coroutines, and then in official Java JDK, we have something similar, virtual threads. Does it make sense to use Kotlin? Kotlin developers doesn't like your question, of course. But to answer your question, you have to go deep into the way that they handle context. It's not all about this. So sometimes you need. I believe that you have to. It has to be practical. Then you can compare. But in this call, one of this one, there is they also provide a mixed approach. Imagine you are using Kotlin coroutines in Project Loom. So so it's very complex. But me personally, if I see that Java is adding more and more these fancy features from other languages, I don't see much benefits on coroutine side, but it's just my opinion. So I'm not expert. I don't consider myself as expert, but yeah. Is it readable here? Or?
It's about hamburgers, right?
Yes, it's all about food. Okay. Zoleve?
Yeah.
Okay, welcome back. So as I said in the presentation, we are going to go a bit dive into Project Reactor. Though Project Loom is very fancy, but there are still quite a lot of use cases for Project Reactor. And I've been working on Project Reactor for 2 years. So the idea is to share some of the experience that I had with Project Reactor. So before we start here, I have around 20-25 unit tests. So we go step by step. We create a signal, and we kind of incrementally add things to our pipeline, basically. And before I start, I want to just show you what is the use case of this workshop. So, of course, I have a burger object. It's very important. And I have a burger request adapter. I think you Java developers, Spring developers, you always have adapters, right? You get something and you want to transfer it to something else. And we have a burger HTTP client. Imagine we are a delivery service. So when we receive a request, we have to order the actual burger, basically. And then imagine we have like an event-driven system. We have to publish. So before we publish, again, we have to adapt to an event and publish it. And of course, in all of our use cases, I'm pretty sure that most of you have, there are some configurations somewhere. You have to write your logic based on that configuration. Like if it is a spicy burger, make it green, something like that. Make it red, something like that. So with this context, I am gonna start. Before that, Marcus, how much time do we have?
3 minutes.
3 minutes, okay.
I mean, the official runtime is until 8, but I mean, if people are okay with it, The room will not close, so we can stay a bit longer.
All right. So let's look at the very first example. So in this example, I just start. So mono is about a one item or zero item. It can be also an error signal. I'm starting my pipeline with the object with the burger object, and of course, so if I show you this adapt method of this adapter, the implementation. Oops, too small. So you can see that this adapt method is returning a Java object. It's not mono or flux. And that's exactly why I'm using a map. And then when I adapt my burger object, then I'm going to call this client. And remember, I told you that that when you are using reactive project Reactor, all the libraries, all the stack should be reactive. And the classic web client in Spring is the web template something. But when it comes to Reactor, you have to use web client. And web client is the one that the methods are returning either mono or flux. And you can see that my book method is returning a mono of a response. So imagine this is calling some service and getting the response as a mono. And that's exactly why I am putting this as in a flat map, because the return type of again the return type of this method is a flux or is a mono. And then again I have a simple adapter. If I open the implementation, this adapter is not returning a mono or flux. So that's why I'm using a map again. So in this case, imagine you are publishing to Kafka something saying that the order is done, and of course the publishing is a blocking call, and it could return a mono or a flux, and that's why in my very first example I put in a flat map. And I'm going to run this example, but before I run, this step verifier is a class that is introduced by Project Reactor to write a unit test. Basically, when I have this pipeline, I'm creating an object in this pipeline and passing it all the way through. So at the very end, what is here is returning a mono of a string. So that's why so this all this pipeline is wrapped in a mono object, and when I pass this mono object to a step verifier, then I can expect something. So at the end, this method is not a real implementation, but at the end it's returning a succeed string. So all the way through this pipeline, if I pass this mono to a step verifier, I expect one succeeded item, and then I can verify. It's very important in Project Reactor that the pipeline is over. The pipeline is completed. So I'm going to run the very first example. So you can see that this passed. So this means that this whole pipeline returns a succeeded. Going to our next example, so I just put this lambdas here to make it more readable. Thanks to IntelliJ, if I just try option enter, there is an option replace lambda with method reference, and that's exactly my second unit test. This is exactly the same one, but all the lambdas are replaced by a method reference. So I'm going to run it, and perfect, it's working fine. Going to the next example. Yes, it's just the same example, but instead of using lambdas, it's just a language syntax.
Oh,
if you put, yes, it's just instead of lambda, I'm using method references. Does that answer your question?
Yeah, I've got a list of.
Yes.
Sorry, I've got another question. The map and the flat map.
Yes.
Are they methods provided by Reactor?
Yes, Reactor.
So this is not the same map and flat map provided by the Java 8 language?
It's not a Java Stream API.
Okay, so this is a different implementation. It's the same.
Yes, same terminal.
The top of the file quickly.
Yes, which one?
The imports. Just quickly.
The imports, of course. So the flux and mono is coming from project Reactor, and we don't have anything else. Is that clear? So if you have questions, please ask, because we are going to add something on top of this example. So no more questions? No? Okay. So my third example is that changing the signal to empty. So what if a signal, so I am passing a burger object, and then I have this filter here. Again, since you mentioned, it's very similar to Java Streaming API, but here it's making the signal empty. I'm going to run the previous example again, just to show you that I'm printing some logs. So first I'm adapting to request, and then I'm calling the book, and then I'm adapting to an event, and I'm publishing. So I have these logs to show you what's happening in the pipeline. And then here, we come to here. I'm filtering out. I'm only interested in the one that has BID2, which is not the case. So what the rest of the pipeline is exactly the same. And as you can see in the previous example, I'm expecting one item to be emitted, succeeded. But in this case, the signal is changed to empty. So I cannot expect, if I write an expectation in here, it will complain. It says the signal is completed, but you're expecting something. Nothing is in the pipeline. So this is one way that a signal, using filters, a signal can be empty.
But is there a way to test its end?
This one, exactly this one.
It's verified.
So if I can show you actually, expect next and succeeded.
Is there something like an expect empty or something like that?
Yeah. Verify completed means expect empty, basically.
Okay.
Yes. So if I run this, it will complain that you can see that expected on next succeed, but actual on completed. So I cannot. So the signal is empty after that. And if I show you the logs, that's exactly why I put the logs here. Oh. So there is basically nothing, no adapter, no book client, no again adapter, and no publish.
You had expect
Expect next here.
Expect next.
Yes.
Is there also expect nothing or something? So you can verify that there is no.
Verify completed without expectation means expect nothing. So the signal is over, basically. Yeah.
Do we also have a peek method here, like to print something?
There is a log method, but I would prefer to put I put all the logs inside the implementation just for sake of this workshop.
Okay.
So, is there any question about making a signal empty with a filter? No? Then I can move to next one. This is again making a signal with an empty mono. So what does it mean? I have exactly same example, but this time when I book the HTTP client, basically, you all worked with HTTP, and what is the HTTP code for no content? Tell me, 20, 201, 204, yes, 204. So basically, when you are working with web client, if you call a web service, and that web service is successful, but that web service returns a 204. When you delete something, they return 204. And it's very likely that the clients change it to a mono of empty, because the web server is returning 204. And in this example, it's exactly the same, but this book method, for sake of having this workshop, is returning a mono empty. And what do you expect here? Again, after all of this, the signal would be empty. And if I print it, you can see that we have the adapt log here. Can you see the adapt, right? Yes. Yeah. We have the book call, but after this call, the signal is empty. This means that my second adapter and my publish method is not being called. Is that clear? Yes? So next one. Okay, so this is a very good example. Imagine that you have in your company-wide, you have a team that is mainly implementing the configurations. A configuration can be like, if the burger is vegetarian, then this configuration needs to be applied. So this means that your team, which is responsible for handling orders, you should call the configuration service to get some configuration. And okay, calling a configuration service to get configuration is a call, is a blocking again. So it should happen in reactive. But in this previous example, this one, the filter, this is accepting a Boolean, not a mono of Boolean. But when you have everything in reactive, when you call your configuration service, the result can come as a flux or as a mono, your configuration. And that's why the filter when method comes to play. So the filter when method is, I'm going to open the implementation of this isSupport method. It's just a configuration. You can see that I am returning a mono of false. It's not a Boolean false, it's a mono of false. This means that you go somewhere, you get the result, but these are all in the shape of mono or flux. And that's why I can pass the result of this method to filter when. So if I run this again, here the signal is changed to mono empty, and then we don't expect anything. And here the verification is nothing, just verify signal completed. And that's it. Going to the next one. Another terminology from Project Reactor. So we have mono empty, but mono itself is accepting a generic type. You saw that mono can be a mono of string, can be a mono of Boolean, and they also introduced a mono of void. So when you can have this type of mono of void, and when this happens, this turns the whole signal to empty. Mono void means mono empty, basically. And here, where is it? Yes, this one. So imagine all the pipeline is correct, but when I publish, I show the implementation of this one. So the implementation of this guy is returning a mono of void. Forget about then. I can explain it what is then doing. But the important thing is that if you return a mono of void, then you change the signal is empty. This means that everything is happening till here. We are also publishing, but at the end we are not emitting something. I'm going to run it. So you can see that we have adapt, we have book, and we have adopt again. We are also publishing, but then in the verification part, I'm not expecting anything. So this is another way of changing the signal to empty. Okay, so we are reaching to the interesting part. Imagine that the signal is empty. So how can I recover from an empty signal? So this is the place that a switch if empty comes to place. Again, our example starts with a burger object. I am filtering. This means that my burger object doesn't have this BID2 number. So this means that after this line, my pipeline, my signal is empty. But then I have this switch if empty. And this switch if empty happens when the signal is empty. So basically you can have like a fallback scenario.
Exactly same as or else in option.
Exactly. Yes. And so what I'm doing here is I'm calling switch if empty with a cancel method. And as part of cancel, I'm returning something like cancel. Of course, it's not a real code, but let me run this. And you can see that I am expecting canceled. So no more adoption, no more book call, no more again adoption, no publishing, because this guy, this filter, changed the signal to empty, but this cancel is happening.
But you didn't do the burger request to book it first, so
yes, it's here.
Yeah, but that doesn't happen because of the false.
The cancel doesn't make much sense here, but you can say instead of cancel, a refund customer, something like that.
It's about the or else
yes.
Do something.
Yes, exactly.
But if you wanted to do the cancel only if the code went past the book method, can you also do that, or is that?
Yes, it's possible. So what you want to do?
Yeah, I was wondering how difficult is that? You write this, so you only cancel the order if you booked the order. Yeah.
Yes, what I would do is to extract some methods. So this is yes. So exactly. Yes. Yes. Exactly. That's that's a very good question. That's one of the tricks that you have to do when you are working. Remember the presentation. This is a different coding style. And when you are writing code in Project Reactor, you have to do some tricks. Sometimes you have to extract some methods that you don't like, but sometimes it's necessary. You cannot handle everything here. Yes.
I can imagine if the client was already like in a parallel something being executed, and then there's a timeout and you do a cancel, that would be helpful though. I'm not even sure if this is possible. I'm just trying to imagine what could I do with a cancel.
So it's just changing. So you can imagine a default value. So going back to our example, we go to a config server to get a configuration. It could be that the case that configuration server is down. You have to have a default value. Yes.
It's just an implementation that we put if we want to, if else.
Yes, exactly. Finally, not in that sense. It doesn't have, but we'll come to in the next example. I have changed the signal to error, so we have something to see there. Handling empty signal with a lazy mono, and this is. Yes, this is actually one of the important things that it could happen. So that in the previous example, you saw that this filter changed the signal to empty, and because of that, this guy was executed. But here, I don't have that filter. So I have switch if empty, and I'm going to run this example. Okay, but something is wrong here. So everything is okay, but why this guy is called? Can you guess why? And one of the rules when you work on a reactive project reactor, you have to be aware that you should try to write as less as possible imperative code. And I can show you. Because of the way that Java works, this is at the end of the day is a method, right? Is a method in Java. The project reactor is not changing the syntax of Java. So at the end of the day, this is a method, right? And when in Java, when you pass something to a method, the JVM first needs to evaluate this value to pass to a method, right? And because of that, you can see that I have a no here. I have an imperative code. And since when I pass this cancel, the result of this cancel method, project reactor should build this one and pass it to this one. So that's why the cancel is being called. The code before, the code behind the pipeline itself is being called. And what we can do to avoid this is simple. Exactly. So we have this mono defer remember this keyword if you are interested in this concurrent programming in Kotlin coroutines. And of course, I think in Loom we have this differ. So we are making things lazy. And using this mono differ, I am just making a reference to a function, not passing a result of a function. So in this way, I can make sure that, oops, yes, I can make sure that the cancel is not being called. And yes, of course, they have another method. This doesn't accept a mono or a flux. This just accepts a value. So you change, if the signal is empty, you just directly pass this. This doesn't have any concern with being lazy. So you just pass. So I'm just running it to see. The filter is, the signal is empty. And then I'm defaulting it with default. Of course, I can expect this default as a result of this whole pipeline.
But there's no default if empty function? It's more like a supplier.
Which one? Up.
Yeah,
yes.
Instead of differ,
switch
if empty function. So something called up? Is it possible? Instead of switch if empty,
yes.
Do we have something like switch if empty function?
Switch if empty.
No need to
switch if empty. No.
No.
Okay. And we indeed had a problem with this. If I want to explain our experience in my previous project, we had a case that everything went well for booking a ticket, but somehow some record was about to be cancelled. Why? And it took time for us to see, okay, we are doing something wrong with this. That's why we have to be careful when you write Project Reactor. You have to make sure that you write as less as possible imperative code.
I don't like more than this.
Okay, so enough about making the signal empty. We are making the signal error. And I'm going to start with this one. Imagine I get the burger object from our customer. And in the first step, I'm trying to adopt, but this adopt is error prone. So always it throws an exception, this adopt, right? Okay. I'm going to run this. You can see that I am verifying error message, and that's because this line of the pipeline changed the whole signal to error. And when the signal is error, none of this will be executed. And I am I'm throwing an exception with this message. So that's why I can verify that the pipeline is an error signal with this message. So moving forward.
Checked exceptions also possible? So this was a runtime exception?
This was a, yes, checked exception is what? Checked exception, yes, but we'll have something better. Okay.
So you accepted runtime exception, right?
Here is, yes.
And can you go back to the...
Yeah.
You check here the verify error message.
Yes, there are other verify methods. Yes.
You have to check the type of exception.
Yes, of course. Yes, that's possible. That is for sure. That is everywhere in the unit test frameworks. So next, yes, this is also interesting one. So before that, I'm starting my pipeline with a just and just passing a concrete object. This is, I start the pipeline with this one. But here, I'm a lazy developer. I'm starting, so the second one was to adapt, right? I'm starting my pipeline with this adapter method. So one less line, right? But can you expect what's happening? No, because again, it's a Java, and this is at the end of the day a method. So when I pass this method, so first JVM evaluate this method to pass whatever it returns, And then this guy is the error-prone guy, is throwing exception. And that's why I cannot assert this with a step verifier. I'm just writing a unit test because it's basically this whole call throws an exception. It's not about changing the signal anymore. And that was another mistake that I saw that some people made. So everything should happen as part of the pipeline. So it's always safe to start your pipeline with a simple object. This guy is not error prone at all. So it's an object you start. Unless I explicitly send null, this is of course an error. But then when I do map, when I do things as part of a map or flat map, this is inside pipeline. So the project Reactor will take care of the exception handling. So you had a question.
How so you can put in the test is expected exception.
Which one?
Line 1, line 3.
Line 3?
Yeah, at test. With a little bit.
So the annotation.
Expected.
Parameter.
Expected exception.
Like this?
That will.
No. Within the test is a pretest.
Yeah.
So.
Can
Parentheses of the braces expect equal to then runtime dot exception dot class.
this line?
Annotation.
Oh,
Yeah.
this one?
Yeah.
Oh.
Expected.
That is possible, but yeah, that's like a unit test.
Yeah.
Writing code, yes. And yes, sometimes, as I said, so it's always recommended to start your pipeline with something simple. Passing an object is not error prone. And then if an error happens, of course it's okay. And then the signal is changed to error and we can verify the signal. We don't need to do something like this. But sometimes it's not even possible to start your pipeline with a simple object. That's why you have in Project Reactor, you have from callable. So you can wrap your call in a lambda. So you are not executing this method. You're wrapping it to a reference and you're passing it to Project Reactor. This is again part of your pipeline. So if something happens, which already is happening, is throwing exception, then it's part of the pipeline and I can verify the error signal.
Yeah,
Yes?
but they don't provide something like this wrapper for the switch if empty.
They accept publishers, so they have to use differ. And I have some couple of examples for recovering from error signal, and this is one of them. So here, let me run this case again. So the signal is error from this line, and you cannot see any of these logs. No books, no adopt, no publish, right? Here, again, I am starting my pipeline with an object, and the signal is changed to an error, but I have here an error resume. And this on error resume accept an exception, and it allows me to provide another mono. So basically, I'm recovering from error. I'm saying that if I fail to adopt, then replace with a new burger request. And one important thing to mention here that it's Java. It's a type-safe language, right? Why it's the place that you put on error resume, the type of the mono that you have to provide depends on the previous one. Since the result of this one was the mono of burger request, I have to provide if I want to recover from the error. So that's why I'm pushing a new. So from this line, the signal is again healthy, and I can run my code.
So if you do it after the flat map, then you need a mono of burger.
Exactly. That's a very good question. Yes, exactly.
And is the flat map is asynchronous because in parallel streams generally flat map is not asynchronous, right? So
That's the rule in Project Reactor. Map for simple functions with the signature returns just an object. Flat map for methods that returns mono or flux. Basically publisher interface. They have a publisher interface. And going to the next example, Marcus is going to kill me, right? No?
Maybe your colleagues are going to kill you.
Oh, so sorry for keeping you this late. So recovery from error, and you can see that's exactly the case that you mentioned. Now the on error resume is not happening right after the map, but it's happening after. So what I'm providing, because the previous line, thanks to IntelliJ, it's showing the types. So the previous line is the result was a mono of burger response. So I have to provide a mono of burger response, and I can simply just run, and it works fine. So you can each step that you want to recover, you have to cover something that it used to be.
How often do you get this in the real world, that you can call a service and then just continue if it doesn't work? It doesn't seem like it happens.
But yeah, there are some scenarios that you can do. So I have to say, in the project that we were working, we used them quite a lot, and we used to do code reviews like hours to talk about which line we should put on error resume, which is the more safe part. But yeah, it was painful at the beginning. But when the whole team get used to it, it's a beautiful work basically, and it could handle, I think, 20 or 30 requests per second. That's a lot. So yes, which one? By the way, this repository, I made it public. You can pull and play with it. So.
Why is there 3 statements, not 4? I expect 4 statements.
The burger client is not printing in this case?
Which one? This one's.
Line 237.
So the result is, so we are adapting this guy. This guy is changing the signal to error, and then it is error signal. So this is healthy one. This is not being executed. So that's the point that he mentioned.
Yeah.
So basically, you write your logic, but then you can say, at any of these steps, something happens. I have this fallback logic, and you can play around this.
I'm a dumb question, but.
No question is dumb question.
Well, this looks like a lot like the regular Java streaming code, but if you execute this, then all the function calls are happening in a separate thread or something, right?
There are quite a lot happening, because Project Reactor is all about, so you have worker threads, they are handling things, and it's far away from Java streaming API. But the syntax is similar.
Yeah. It's just easy to forget because it looks so much like regular streaming.
Yeah. So we have our lovely friend do on success. So imagine we were working on an event-driven system. On each step, if something is successful, we have to publish. If something is failure, we have to publish. Say something all over the line, down the line. Sorry, to say something is happening. So we have this lovely do on success. Now I'm putting do on success at the very end. So if I run it, of course I have do on success. This means that if the signal comes here and it is still healthy, then this will happen. And in my next example, do on success, I put do on success here, and then I have a guy who is throwing exception. So this means that I have do on success. Of course, I started my pipeline with the object. I have do on success, but then the signal is changed to error. So this The rest is not happening.
And empty mono is still success? If the mono is empty?
Empty success. That's a very, very good question. Empty mono is success. Yes. Error mono is not success. Yes.
Only the error is.
Yes. Yes. So remember the presentation. A mono can be 1, 0, or error. And it gets more complicated when we go to Flux, because if you have like 100 items coming, if one of them returns error, then the rest of the flow becomes error unless you recover. So you have some methods, yes. We have, of course, do on error if something happened. I'm changing the signal to error. None of these codes are being executed. RAM is going to kill me. And do on error, it's printing just do on error. And using do on error again, what is this? Yes, this is a very good example actually. So here I'm starting the pipeline with an object. This guy is throwing an exception, so the signal is error, right? And then do on error is being executed, and then I'm recovering from error to a request, and then all this is being executed, and I have do on error, and I'm expecting what? So I have do on error 1, but not do on error 2, because the signal is recovered to a healthy signal, basically. Yes, and that's actually one more important thing about the project Reactor. Remember from a slide, project Reactor is a more Spring-ish way of doing things, and I'm assuming that you are most likely, if you write project Reactor code, you are using it in a web application. So your controller starts with a mono or flux, and then all the way you have everything. And by under the hood, a Spring framework is subscribing your mono or flux. In all this unit test, this is the step verifier guy who is subscribing to make it happening. Yes, and when you use a Spring web flux, a Spring under the hood, when a request comes, it's subscribed to the mono or flux. But there are of course some. Where is it? Do on error is here. Of course, like a Spring web flux, this step verifier is subscribing this mono, so no problem at all. But I have all these do operations. They accept a lambda, that is perfectly fine. If something happens, the lambda is executed. But they also accept. This guy is returning a mono, and a Spring framework or this step verifier is subscribing to the main pipeline. But if you pass another mono or another flux, you have to manually subscribe it. Otherwise, it's not being executed. So that's one of the important things to know about Project Reactor. Yes, and I have just a few examples about Flux. I don't know how is our timing. Shall we continue on Flux? Yes?
The room is unblocking.
Okay. So this is my first example of Flux. So I have objects, Burger Object 1, Burger Object 2, Burger Object 3, and it's just imperative code, is a list of objects. And I can start a Flux from an iterable. So this from here, I have a flux of burger, and flux means one or many items. And I can do the same thing. Basically, I can adapt, I can book, I can again adapt, and I can publish. So I'm making it a bit fast because it's getting late. And as you can see in my expectations, because this last step is returning a succeeded. As a result, I'm expecting 3 succeeded methods, and then I'm expecting the signal to be completed. So I have all of them, and the signal is completed. What is this example? Yes, since you mentioned, there are other ways using, this is just a testing framework. I can expect exact values. Of course, when it comes to many, it might be the case I cannot write all of them. I can expect count. So I'm expecting 3 items to be published. And yes, so this is a good example about fluxes. So I have again a flux of 3 items. I'm at the first step. It's throwing an exception. This is again the same method. So it's throwing an exception. So if I run it, you can see that I'm not expecting anything. Why? Because in a flux, if one item is throws exception, then the whole signal will be an error. And how you can recover from that? Mix error and signal. Yes. So this is another example to show how flux behaves when it has an error. So I have burger 1, burger 2, burger 3. And this is a customized adopt method. This only throws exception when the ID is 2. So the first item comes through. This is success. The second item, exception, change the signal to error. That's why I'm expecting 1 succeeded and 1, and then verify error message. So first item is successful. The next 2 is error message. Is not happening.
Next 2 or next 3?
1 is successful. So because this is a customized, so I have 1, 2, 3. This only throws exception when the ID is true. I made it.
ID 3 should be successful. Right?
That's exactly the purpose of this unit test. When the signal is error, the rest is error.
Oh.
Yes, unless you recover from error. And a recovery from error. So basically,
when the second one is throws error, the third one will be run.
Will not be run.
Will not be run.
No. So the other example he's going to show that it has an on error resume, and then that's a specific. Okay, if you find the error, check.
All right. So of course we can use filter. I'm filtering out the ID 2, then the other 2 is successful. This makes sense, actually. And I have 2 more left to recover from error. And the difference is that I have on error resume and I have on error continue. Basically, on error resume means that change it to a one item. This means that this guy is throwing exception on ID 1. So the whole signal is 1. So I have 3 items. The first item throws exception. The whole signal is error. But I'm recovering to a 1 item of successful one. That's why I am expecting only 1 succeeded. You might ask, okay, what if I want to just skip that problematic one? That's the place that we can use on error continue. So I can, it accepts a trueable and a burger, and I'm printing basically if you want to skip, yes?
So if you do like on an error resume, in this example you return the monad not just to create them.
Yes.
Not an empty monad, but could you return an empty monad?
Yes, of course you can. You can change the signal to empty, and then that's it.
The rest of the steps won't.
Exactly. Yeah. And yes.
Can you also do both, resume and the continue?
Yes, you can extract method always. Yes. And I think that is the last example. Basically, I am skipping the first one. And you can see, you can do whatever. I'm just printing something happens. You can do whatever. You can refund the customer or whatever. And here, you can see that error happened, but I have both the other healthy signals happening.
That from bug ID 2 and 3.
Exactly. And that's a good bridge to the problems with this. So you're asking about ID1, ID2. That's the context that we need to pass through these whole pipelines. That's something, if you start working on any kind of these libraries, you need to first read about it. The contexts are complex. That was it. Thanks, everyone.